In this case, we proposed UAV-borne narrowband radar codes for direction finding. Okay, I can stop at this point and answer your question. Yes.
Okay, just one small question. Have you performed an experimental study? Because yes, it is a computer simulation.
Not yet, but we are going. It will be the second year of our project of Ministry of Education, and on the next year, to 2024, we are going to realize it practically, and we have some idea for two types of direction finders. The first one is realized on analog elements. To measure this power using like amplifiers, filters, power detectors, and then analog to digital converter, and or maybe just some analog scheme for measurement for subtraction powers or maybe dividing powers. We have such analog schemes too. And
okay, thank you. I just would like just to add that in civil aviation we have the same problem, because there is a ground and there is a refraction from the ground, and it change a gain function of antennas, and that's why it is like also quite big problem with refraction from the ground. Because these antennas will be mounted near the ground, and it will be some multipass effect. Okay, thank you, Semyon.
Okay, and the other type of such system we are going to realize fully using SDR receivers. So we are going to realize it on Pluto Plus or maybe some other receivers as it's going to be presented today using HAC RF or maybe other, and fully at frequency 2.4 GHz, just receive signal and then realize these algorithms in any Raspberry Pi on the aircraft board. And in this report, we would like to add also phase direction finder. In this case, we propose to implement our system on UAV with with wings, and to do this we propose for wide antenna pattern receivers. We propose to use maybe for frequency 2.4 GHz. We propose to use the typical antennas for Wi-Fi with wide angles of view to realize unambiguous measurements, and to make antenna with narrow beams. And it's the same that we can implement it to place it on the wings. We propose to use Franklin antenna. It's narrow. It has its directional antenna with relatively narrow beams, and the length of wings allows us to put this antenna. And in front of our UAV, we propose to insert two omnidirectional antennas for phase detector. And in this case, we have stated signals, like 4 of them you have already seen. And the fifth one, we do not take into account in omnidirectional antenna characteristic of antenna patterns. We just get the antenna gain then characteristic of complex envelope, and take into account in our signals phase characteristic. Like the central phase center is between our antennas. That's why in one equation we have minus d cosine theta s divided by c, where c is the speed of light, and in other case plus d is the base of our phase direction finder. And we also calculated likelihood function, found its maximum, developed likelihood equation, and found two possible algorithms. Four components of this algorithm, they are the same. They show us that we have to measure power in every channel using some coefficients and some derivation of antenna pattern. It means that we have to measure slope for every antenna pattern and take into account the slope as the weight function in all of this algorithm. And other part, firstly, we got the difference of phases in one channel and in other one. But as for me, it's quite difficult to measure phase in such system. For aircraft, for like air defense systems, yes, it's necessary to develop like some oscillator, some phase control system, phase loop system. And in this case, we can measure phase in every channel. But for UAV, especially if they use if they have to be low pricey, we propose other way of measuring. We propose to make a difference and sum of signals from this two of this phase measurement, phase receivers, and then find division, or maybe or maybe multiplication and division of energy into channels, and then and we have in practice such electrical schemes that measure division of two signals, or maybe multiplication of these two signals, and measure phase difference in this way. So we've got this big fifth part of this algorithm that realized quite difficult, but practically it's going to be not so difficult. And to this realization. And the third one, we just did not present. We can just measure phase in one channel, in other channel, and make the subtraction. And also it calculates into direction. And we found the limit errors of marginal errors, and we did some simulation and found discrimination characteristics and its slope, and we proposed this the black line. It realized 6 antennas direction finder. It has relatively wide unambiguous measurements of direction, and at the same very narrow very high slope in the center of these measurements. And the idea was like this, that we have that we have direction finder with wide antennas. We just catch this signal and start to direct our UAV in that direction, and do not take into account signals from narrowband, narrow antenna direction finder, and from phase direction finder. Then, when our target, let us call, come to narrow beam direction finder, we start to make something. We start to take into account this narrow beam direction finder, and when our measurements is like in equal direction, we start to use also phase direction finder that has the highest quality in these days, but at the same time it has very narrow unambiguous measurements of the direction. So this all the results that are prepared, we were tried to uh, to solve contradiction between direction finder accuracy and the width of the range of unambiguous measurements, and to implement this on UAV. Thank you for your attention. Question, please, Professor Ostromov.
Yes. What type of antennas would you propose to use on board of UAV? Because UAV could be quite small, and if you would like to use like 4 antennas, it will be a little bit difficult to mount like many antennas on board of small UAV. Okay.
Yes.
Do you have any suggestions for
Yes.
types of antennas?
For narrow beam antennas, we propose to use such one Franklin antenna. It's very good, can be placed this one, or maybe it can be shown this one. We have done some experiments. It can be calculated relatively easy. It can be made on PCB, and this antenna, it has only big size in one direction, and this direction, it has to be coincidence. This direction has to be placed on the wing. So this system can be implemented only on the UAVs with wings. The length of wings can be used to place this antenna of Franklin antenna. And for wideband,
Okay, thank you. I understood that. That's why it could be mounted inside of the wings. That's why we do not need to place like external antennas. It will be in the body of wings.
especially in that one that are made of some material that is transparent for electromagnetic waves. Okay.
Okay, thank you.
Do you have any questions? Okay, thank you for your attention.